Thank you. So, as Benny said, we are going to talk about the WOMBAT project, which is a project funded by the European Commission. And my name is Olivier Thonnard. So on the left, I am working for Symantec Research Labs, and this is Andy Moser from the University of Vienna. So just a few words about us. So Andy is a postdoc in Vienna, ISEC lab, and as I said, I'm working for Symantec. So I used to be an officer. Now I just resigned from the army, and quite recently I joined Symantec to work as a researcher. So what is it about here, the WOMBAT project? So you see here, it's funded by the EU in the context of the Framework Program 7. And you see here a list of partners that are involved in WOMBAT. So basically Symantec is partner, but also TU Vienna, Forth, Orange, Eurocom, ISPASEC, as you may know, is running the VirusTotal web service. So in fact, in WOMBAT, our approach, there are three work packages, which are the following ones. You have the first work package is about data acquisition, so there on the left. So in that work package, what we did before, because the project is running since 2.5 years, what we did, we developed and integrated different kind of sensors in order to collect security events. Then we use different kind of sensors. So we have a few examples there. We use honeypots, client side and server side. We use crawlers. We use also external feeds. We have a sandbox also. So I'm going to talk about that a bit later. Then in the phase 2 of the project, we enrich the data that we collect in order to add some more data, what we call the metadata. And then today I'm going to talk a bit more about the work package 5 here. So that's the third pillar. And the third pillar is about threat analysis. So what is it about in practice? Well, as Ian said in his talk this afternoon, in WOMBAT we want also to connect the dots. So in fact, I think that everybody has played that kind of game when he or she was younger. So the purpose is to connect all dots in order to expose the big picture, hopefully. And when you do that here, it's quite easy because you have here the numbering, so it's quite easy, and you see then a nice shuttle. Of course, in the internet it is less easy because you don't have the information about the numbers here, so you don't know how to connect those dots. So how to figure out how to connect the attacks that we are seeing with different kind of sensors in order to find the root cause. So this is what we try to do here in WOMBAT. So in order to generate the dataset, what we use, you have a few examples of the datasets that we use in WOMBAT. We have a dataset called SGNet. So SGNet is a network of server-side honeypots, and the scriptgen sensors are able to learn about new exploits. So it's really a new kind of sensor. Then we have Hammer. Hammer tells us things about the dynamics of client-side threats. Then we have a sandbox called Anubis, for those people who know about it. So every piece of malware that we collect through any kind of sensor, we submit it to the sandbox. And we get, of course, the report about the behavior of that new sample. We do the same for VirusTotal here, so it's a malware scanner, and everybody knows about it. So they are also a partner in WOMBAT, and every piece of malware that we collect, we submit it to VirusTotal. Then Honey Spider is also a honeypot, but on the client side. And WIPAWet is, strictly speaking, not a partner, but we use their service to add some more data to our collection. So you have an idea now of the dataset that we have developed. Now, the purpose of WOMBAT is to share that, and it is not easy to share such kind of data because of some privacy issues. What we did here, we had a layer. We have developed an API which is called the WAPI, there, the WOMBAT API, and the API is developed in Python. So for those of you who know a little bit of Python, it's very easy to use it, and it is based on SOAP. So SOAP allows us to make requests to any type of dataset. So we deployed the WAPI on all the dataset that you see here. And in fact, we don't have so much time today to give a demo on how to use it and with code snippet. But still, you can go on the website of the project here, and you will see in the proceedings of the workshop that we organized last year, we have given a demo to CERT to show how to use this WAPI code. So just to give you one last schema of what the project tried to do. So we have done this before in the first phase. We have developed all the dataset. Then we have added another layer here, the WOMBAT API. And then today I'm going to talk a little bit more about triage and fire. Fire, Andy is going to talk about that in a few minutes, in 20 minutes. And I'm going to talk about threat analysis by means of another framework. So just to give you an idea on two different approaches to analyze and to look at all the data that we observe in the internet. So this layer is mostly about threat analysis and the attribution of the attacks that we are seeing. Okay, so let's start with the part on attack attribution and threat analysis. So Voltaire has said that chance is a word void of sense, and there is always a cause for all the things that we observe. So now it is difficult to figure out what is the root cause, and this is the purpose of what we try to do in the last phase of WOMBAT. So we talk about the attribution. So what is that? People used to talk about that when we wanted to do what we call IP traceback. So this is in the case of a DDoS. We are not talking about attribution in that meaning, but here we talk about attribution in the sense of identifying the root causes of the observed events, attacks, by linking them together thanks to a series of common features. So it is really about connecting the dots, and it is a bit similar to, the criminals in the cyberspace. They have the same modus operandi as the criminals in the real world. So they are going to leave some traces. They are going to leave some fingerprints, and what we try to do is to unveil those fingerprints by linking the events based on a series of common features. Now, how to do that is very difficult, because there is a danger, of course, that data mining and clustering. When you cluster data, you will find clusters. So you will find patterns, and it's a bit like a child who looks in the sky and he can see clouds. And when he sees clouds, he will say, well, that looks like a cat, and then another one will tell you, well, no, it looks more like a dog. So it's a bit like that. So you have to take care on how you cluster things. And just to show you a little picture of the danger of this aspect, well, you see here the policeman who there is one that tries to interpret something that is not present, of course. So what we did in triage is a bit different to the clustering that we used to see in other domains. Here, in this case, triage is in fact a multi-criteria decision analysis technique. So we use the MCDA technique to link the events together to the same phenomenon. So basically, this is the approach. So you have, for example, a set of events here. Basically, you select a number of features. So it can be the location of the attacks, it can be the IP address, it can be the target, it can be the type of exploit, the type of malware. So you put as many features as possible, but preferably features that do make sense, of course, that you know that if you link them by this or that feature, it will make sense. And then when you have selected those features, what we do in triage is the following. We are going to create graphs that show you the clusters with respect to each feature. So it shows you all the attacks that are linked to the same place, or all the attacks that come from the same area, or all the attacks that share the same kind of shellcode, and so on and so forth. And then in the last step, what we do, and this is really new, we try to aggregate all those different points of view. And the way that you do that is very important, of course. You don't just have to take the average of all the features, because we have shown that usually it does not work. So you have to aggregate all the features in some way that you model the behavior of the phenomena. And this gives you, in the end, a multi-dimensional graph where you can see all the relationships that make sense for a given phenomenon. So this step, we create some viewpoints here, and here, this is a data fusion step where we try to aggregate all the inputs in order to hopefully expose the big picture. So this is the main idea. So this is quite novel, because here there are few people who try to aggregate different points of view by using an MCDA technique. And actually, I've shown in my thesis that you can, in fact, find if you Google, you will find it. I have shown that if you use the average of all the criteria, so for instance, two events that seem to come from the same place, but more or less, then they share a number of features, but they are all, 0.5 and not really 1, but 0.5. Well, you are going to link together events that are probably or very likely not due to the same phenomenon. Whereas if you use other kind of aggregation function, such as an ordered weighted average, or if you use an integral of Choquet, then you can model the interactions between features. You can model behaviors that are more complex. And that's all the point of this approach. Like, for example, if you use an ordered weighted average, well, the weights, you associate some weights of importance to not to a given feature, but instead you assign that to score ranks. So the highest gets a certain weight, and then the second another weight. And if you take, for example, some weights, like here you have 5 features and 5 weights, and if you say that the first feature, even if it is the highest one, so there is a correlation that is really high for